All right, so some of the problem for the last problem, number 21, got cut off as I was explaining it. I'm not going to redraw the picture, but when we looked at it, we saw that side AD was congruent to JF, DC was congruent to HJ, BC was congruent to HG, and side AB was congruent to GF. I didn't realize that the recording had stopped until I started erasing the problem. So essentially, polygon, this is the congruency statement. Polygon ABCD is congruent to polygon FGHJ. And so number 22 is identical to this type of problem. So I will let you guys do this on your own. And essentially, I'm going to move on to the next problem that is a proof. This is a kite problem. It says for number 25, it's basically we have a given statement right here, given WY, segment WY, or side, segment WY bisects both angle XWZ and angle XYZ, and wants you to prove that triangle WXY is congruent to triangle WZY. And here is the kite. So we have X, W, Z, and then we have Y right there. So as I discussed the last problem that we did, that was a 2-column proof. Essentially, what we did was write 2 columns where we had a statement that was given. So statements and reasons. So as I've told you many times in our class, and also just in the last video when we did a 2-column proof on the triangles, we always write down what's given. So we're going to put segment WY bisects both angle XWZ and angle XYZ. And then the reason is kind of like the proof. And we know that it's given. And then I don't know how far down, how many steps we're going to have to go, but as I've explained to you with proofs before, we always want to write what we're proving. So down at the bottom, I'm going to write triangle WXY is congruent to triangle WZY. That is exactly what we're trying to prove. Okay. So we know that WXY, so this angle right here, is congruent to WZY. I always want to basically label what's given. And then we also know that WY bisects both XWZ and then also XYZ. So that means that this angle right here and this angle right here, they're congruent to one another. And now it wants us to prove that triangle WXY, so WXY, is congruent to WZY. So essentially, we know that we have an angle, an angle, and an angle. So it's already been proven that through angle, 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 that that those two triangles are congruent. But I want to take it a step further and go based upon the different properties that we've done before. And I don't think we can prove, because of that what statement that I've had up there, that it is congruent through angle, angle, angle. So if we look W and Y, we could say that it's congruent to itself. So what I want to do is say that segment WY is congruent to segment WY. And that's because we have what's known as the reflexive property of congruency. Okay, so now we actually have proven that the triangle is congruent based on, we can say, angle, side, angle. So we're just going to say that WXY, triangle WXY, is congruent to WZY because we have an angle right here, we have an angle right here, a side, and an angle. So we're just going to say angle, side, angle. Or angle, side, angle. All right, so I'll give you a second to look at that board. Okay, so let's move on to the next problem. So it looks like the only other topic that we have in the unit review that I want to go over, the rest is pretty much covered through the different type of problems that we've done so far in this unit review. I've given an example on every type of problem that's in here, so you can look at the other videos and work on the problems on your own. There's only a couple that you have to do without videos, but it's because they're identical to the problems that I've already covered in the other previous videos. So I just want to go over the last topic to help you with this unit review. So this is problem number 29, 30, 31, and 32. Okay, so these problems say identify the type of congruency transformation shown as a reflection, translation, or rotation. So we have on this axis so we have an x and y axis, and on this axis we have a diamond at -2, 0, and And it goes something like this. Right there. And then we have it at and it goes something like this. So if we look at this, it wants to know, again, if it's a reflection, rotation, or a translation. So reflection is if it's like a mirror image, like we've reflected over a certain line. A rotation is if we've taken it and spun it around a certain point, and a translation is if we moved it and it stays the same, basically the same rotation, except we just moved it over. And I know that this drawing is a little off, but essentially we moved this over 4 units to the right, and then we moved it down 2 units. So we moved it over 4 units to the right and 2 units down. And because we moved this diamond and now it's over in this location, that's going to be a translation. All right. And then for number 30, we have these parallelograms right here. And it looks like it does something like this, like that, and then also like this. And if you look, this is clearly a reflection. So number 31 is a reflection because it's a mirror image. It's reflecting over the x-axis. So if we were to take this on a piece of paper and fold it over the x-axis, it would basically land on top of each other. But essentially, it's like a mirror image. If you were to hold a mirror up right here and the x-axis was the mirror, it would be a reflection. Notice how it's like a mirror image of the shape. That's why it's a reflection. And then that was number 30. And then for number 31, we have a shape Sorry, I'm trying to pull it up. The Chromebook logged out. Okay, so we have a shape that looks like this. Notice how these two triangles are pretty on the piece of paper. I know it's not drawn the best, but essentially this again is a reflection because at this point right here, these two triangles are mirror images of each other if you were to reflect it over the y-axis. So this is a reflection, and it's because there's a reflection over the y-axis. It's a mirror image of each other. And then lastly, we have this shape that looks something like this. I'm just going to draw it. Like that. And then also like that. So essentially we have an X and Y axis. Now if you look on your sheet of paper, this right here is going to be a rotation. Because we took this point right here and these 2 points end up on each other. At that point the shape ends up on each other. So let me just kind of redraw that real quick so you can see it clearly. Essentially they share at the origin this point. So since they share at 0, 0, that common point at that tip of each of these shapes, we know that it's going to be a rotation. So if you imagine that you have like, I'm trying to think of something. So if you had, I can't think of the object's name. Basically, if you had a shape and you just spun it at this point, 0, 0, pretend it's rotating this way. This shape, if you spin it around at this point, will actually land on top of this shape if it was to rotate to the right or to the left. It doesn't matter which way. If you spin it, it's going to end up on each other. So it's a rotation. Kind of like a windmill. If you have one of the blades and you rotate it at the center, it's going to eventually land on top of another blade, even though they move at the same time. If one was stationary and didn't move and the other one did move, it would actually rotate on top of it. So you can think of it like that. You're moving this shape right here, this quadrilateral or polygon at 0, 0, and you're spinning it around the axis and it will end up right there. So that's why it's a rotation. Anyways, that concludes the review. There's other problems on the review, a couple more, but pretty much they're the same type of problems that we have done already that I've gone over in the video. So just work on them and try your best and make sure you finish it. Okay, so have a great day and I will see you tomorrow in class.